Hello, General Biology, and welcome to Chapter 4. And in Chapter 4, we're going to talk about the climate. We're going to talk about climate change, and we're going to talk about the things that affect our climate. Again, we want to think sustainably about how we can conserve and protect our environment to slow down climate change. Okay, so this is section 4.1 and the first in the screencast series for this section. All right, so when I'm making this is summertime and Hurricane Harvey is hitting Texas. It hit Texas as a Category 4 hurricane, and because of the jet stream and the systems in play, it actually hit twice. It hit landfall, went back out to sea, picked up a little bit more energy, and then came back in again. And they're predicting that in the next couple of days, a total of 30 inches are going to fall on Texas, areas of Texas, Corpus Christi, in that area. It's a dramatic storm, just like we've heard about Hurricane Katrina, which flooded New Orleans. Sandy, which happened a few years back, that hit the northeast coast. We also hear of droughts that happen in the southeast. I know Arizona has not had a lot of rain this summer. Oregon, which typically does have a pretty good amount of rain, has also experienced higher temperatures, and they have not had as much rain, and that's because of the climate. The climate is changing. So when we talk about big storms, seasonal droughts, we're actually describing the weather. We're describing weather is day by day. So we're describing what's happening day by day. And when we talk about the year average, the general amount of precipitation and temperature over a period of time, then that's climate. That's what we mean. So climate is different than the weather. Weather is day to day. Climate is over a longer period of time to keep track of the precipitation and temperatures. So one of the things that we need to understand is how climate and weather will affect organisms and ecosystems. Again, we'll watch this video in class. So our key concepts, we're going to find out what climate is. We're going to talk about a region's climate and how it's defined by the year after year patterns of temperature and precipitation, as I've mentioned. Okay, so again, repetitive here, weather, so to reinforce this, the day-to-day condition of the Earth atmosphere. The weather today, it was nice and cool. It was about 79 degrees, low humidity, sunny. That was the climate for today as I'm recording this. Climate, though, refers to the average conditions over a long period of time, and it's year after year patterns of temperature and precipitation. So when we talk about the area that we live in a temperate forest, and our temperate forest region typically has temperatures on average that in the summer run about 95 degrees. That's average now. And in the wintertime can run about 30 degrees Fahrenheit on average. We have a set amount of precipitation throughout the year, and that's like 60 centimeters of rain throughout the year. That might not sound like too much, but we get these big storms that do like 2 inches at a time or 1 inch at a time, and that all collects. So the northern hemisphere, south-facing sides of trees and buildings actually receive more sunlight. Oh, I'm sorry, I missed microclimates, my fault. But one of the things that we need to keep in mind is that not always is climate uniform. We might say that a particular area has a characteristic climate, but we can actually have many climates within those environments that create conditions that are different from the norm. And they are called microclimates. And one example, and I'm going to take a different example than the one that I have here in the textbook, and I'm going to talk about lake effect snows. So if we're living in upstate New York off of Lake Erie, they have something called lake effect snows that happen where the weather forecast for the area might be, 30 degrees, sunny, but because there's moisture and wind that's coming over the lake, it can cause it to snow when the forecast is supposed to be sunny. It doesn't have to have heavy clouds in the sky for a snowstorm or a cold front coming in. It could just be those cold winds over the warm lake causing that water to freeze and making that lake effect snow for the area when nobody else is going to have the snow. And that's a microclimate. So we're going to go and talk about what factors determine global climate. We're going to talk about the average temperature of the globe is 14 degrees Celsius. I'd like you to look that up. We've talked about temperature before. 0 degrees is freezing, 23 degrees is room temperature at 72. So find out what 14 degrees Celsius is, because that's the average temperature globally. Global climate is shaped by many factors. That includes solar energy being trapped in the biosphere, being trapped in the ground, being trapped in the oceans, your latitude, where you're located on the earth. Do you live in the northern hemisphere, the southern hemisphere? Are you near the equator? They're going to have an effect on the weather. And then the transport of heat. Are the winds blowing over land? Are they blowing over the ocean? What type of air are they picking up? What are those currents? And these are the factors that are going to affect climate. So the main force that shapes our climate is solar energy, and that arrives from sunlight as it strikes the earth. What you're seeing here is referred to as the greenhouse effect. If you've ever been in a greenhouse, or how about in maybe your sunroom at home, and the light comes through those windows and it really warms up that room. It could be cold outside, and if it's sunny, that sunshine coming through the windows will actually warm that room up. And that's really what's happening. The sun is coming down, and we have a layer of gases that are called greenhouse gases. And these gases contain moisture, so there's water droplets in them. There's going to be sulfur, there's going to be carbon dioxide, there's going to be methane gas, nitrogen, and they create this blanket, this greenhouse blanket. So what typically happens is the sunlight comes down and it's absorbed in the earth, it's absorbed in the oceans, it's absorbed in the land. And as it's absorbed, it heats up the air. So the air will start to, when you have warm air rises, so that air is going to start to rise. When it comes close to these greenhouse gases and they're further away from the earth, that air is going to cool down, and then it's going to sink back down to the earth as cooler air. Some of the light is going to be bounced back. If we're talking about our polar ice caps, some sunlight is reflected back and doesn't get a chance to heat up because of the ice caps. White reflects. Some of it's absorbed, as I said, in the ocean. Some of this air is going to escape and be lost in space. but the other is going to cool back down, and it's going to come back down to the Earth. So this is the heating and the cooling pattern that takes effect by the greenhouse gases. But here's the problem. Here's where we've got a huge problem coming in. We're increasing the amount of carbon dioxide. So we're thickening this blanket. This blanket is getting really thick because of the carbon dioxide. So when the air warms and it rises, it can't go up as high. If up here is 32 degrees Fahrenheit and is freezing, this could be just 31 degrees, or I should say 33 degrees Fahrenheit, melting. The difference of 1 degree is the reason why we're losing the polar ice caps. We actually have a 1.9 degree temperature difference right now. So that's almost 34 degrees, and it's melting our polar ice caps. So what that means is if we don't have the polar ice caps to reflect some of this light back, more of that light is being absorbed into the oceans, and it can impact the temperature. It can raise that temperature. So as we look at this and as we're going over the greenhouse gases, some of the heat also radiates back into space. Some is trapped in the biosphere. The balance between the heat that stays in the biosphere and the heat is lost is going to determine the Earth's average temperature. The Earth's temperature is largely controlled by the concentration of 3 atmospheric gases, and they are carbon dioxide, methane, and water vapor. This methane is really interesting. There's a group of scientists that are studying cows, and when cows gas, that's when they pass gas, they release methane into the atmosphere. And the study, I don't know who decided to study this, but the study is proving that cows really put up a significant amount of methane into the atmosphere, and that's one of the things that we need to be concerned about. So these greenhouse gases, they're going to function like the glass in a greenhouse, like I mentioned, allowing the visible light to enter, but it's going to trap the heat, and this phenomenon is called the greenhouse effect. And that's how our Earth's temperatures stay relatively consistent. If greenhouse gas concentrations rise, as I suggested, they're going to trap in more heat, so the Earth is going to warm. If the concentrations were to fall, more heat would escape and the Earth is going to cool. So without this greenhouse effect, the Earth would be about 30 degrees Celsius cooler than it is today. Okay, so if I said the average is 14 degrees Celsius and 0 degrees is freezing, and we subtract 30 from that 14, it is going to be really cold without those greenhouse gases. Our whole Earth would be frozen over in that case. I'm going to stop here, and we'll pick up with latitude and solar energy in the next screencast.